So today we'll be working with formulas, and the definition for formula is that it's an equation that shows the relationship between quantities that are represented by variables. Big thing about formulas, they have a lot of variables in them, usually more than one, sometimes 2, 3, 4, 5. Okay? The important thing is that we're able to substitute, and we've practiced substitution before. Substitution is when you change letters into numbers. And usually if you read the problem enough, they will tell you what numbers to put in place of what letters, so then it's not too tough. And if you think about some common examples of formulas, like this one, if you travel at a steady speed of 65 miles per hour for 3 hours, how far will you travel? Well, let's see. If you go 65 miles in 1 hour and you go for 3 hours, well, I determine my answer by doing 65 times 3. If I travel at a steady speed of 60 miles an hour, but I travel a total of 270 miles, how many hours have I been traveling? Think about this. Speed, how fast I'm going. I'm going 60 miles an hour, and I'm going for I don't know how many hours, but I know that gets me 270 miles. So I know I'm going to divide by 60 on both sides. And if I travel a total of 400 miles, and it takes me 8 hours, I don't know my speed. But I do know that I traveled for 8 hours, and I traveled a distance of 400 miles. I would divide both sides by 8. So in all three of these, we technically use the same formula. We took our speed, or our rate, times our time, and that gave us our total distance. That's a very common formula that is used. So distance equals rate times time. That's what this formula says. D equals RT. So in this problem, it says my distance is 162 miles. It doesn't tell me my rate, but it says my time is 3 hours. So I write my formula, I substitute the numbers in for letters, and then I can solve it. And that would get me my rate. So your job is to use the formula, D equals RT, same formula for both problems. Substitute, change the letters into numbers, and then solve for the missing variable. So in letter A, it looks like you are missing the rate. In letter B, it looks like you are missing the time. So now's a good time to pause the video and then come back and see how it goes. Alright, hopefully you've had time to check this, try each problem. So in letter A, the distance is 273 miles. We don't know your rate, we don't know how fast you were going, but we know the time was 9.75 hours. So we're going to divide both sides by 9.75. Have to do a side problem. So 273 divided by 9.75. We know our rules for decimals. Move the decimal twice. So I know 975 won't fit into 2 or into 27 or into 273, but 975 will fit into 2,730 twice, and I know that's 1950. And when I subtract, I'm left with 780. Bring down the 0. And 975 times 8 is exactly 7,800. So our rate for this problem is 28 miles per hour, which doesn't sound very fast if you're driving a car, but if you were riding a bicycle, that's really, really moving. So in the next problem, our distance is 540.75 inches. Our rate is 10.5 inches a year times time. Sometimes you might be wondering, well, what moves 10.5 inches a year? I'm not sure. Maybe an iceberg moves that far. Maybe that's how fast a tree grows. But either way, we want to figure out the time, how many years it's been going. So we're going to divide by 10.5. We know this cancels, turns into 1t, or just plain t. And again, set up a side problem. Move my decimal once in each spot. I know 105 won't fit into 5 or 54, but it fits into 540 a total of 5 times. That's 525. Subtract, I got 15 left. Bring down the 7. Fits in once. That's 105. Subtract, I got 52 left. Bring down the 5. And 5 more times. 51 and a half. So our time is 51 and a half years. Again, whether that means the iceberg's been moving 51 and a half years or a tree's been growing for 51 and a half years. Okay? So here's another formula. This is a scientific formula. It says to figure out the temperature in Fahrenheit, you take the number of chirps in a minute from a cricket. Well, in this problem it says there was 100 of them. Take the number of chirps, divide it by 4, and add 37. Well, I know 100 divided by 4 is 25, plus 37. The temperature in Fahrenheit would be 62 degrees. 62 degrees Fahrenheit if a cricket chirps 100 times in a minute. So, here's 3 more for you to try. Again, we want to use the formula F equals n divided by 4 plus 37. You want to use that formula on all 3 of them. So now's the time to pause the video, try all 3, and see what you get. Alright, hopefully you've had time to try these. So we substitute. And once we substitute, we follow the rules of order of operations. 96 divided by 4, I know is 24. And then I add in the 37, and I finish with 61 degrees Fahrenheit. Same steps here. N is 88. So 88 divided by 4 is 22. Add 37 onto that, and I get 59 degrees Fahrenheit. Here, 66 over 4 plus 37. 66 over 4 does get you a decimal, but that's okay. We can have decimals. 16 and a half plus 37 gives us 53 and a half degrees Fahrenheit. And some people wonder, is it okay to have decimals in the temperature? Absolutely. If you think of normal human body temperature, 98.6 degrees. So perimeter. Perimeter, I think of rim, the distance around the outside. So perimeter is the distance around the outside of a figure. And there's a couple ways you can figure out perimeter. One way is just to add up all 4 sides, or all the sides. In a rectangle, there are 4 sides, so we add the lengths of all 4 sides. Some people like to use the formula P equals 2 times the length plus 2 times the width. So you get to decide which one works better for you. In a rectangle, it doesn't matter what you consider the length and what you consider the width. So if I needed to find the perimeter of this rectangle, one option would be to use the formula. The perimeter is 2 times the length, I'm going to call 18.5 the length, plus 2 times the width, and I'll call 12 and a half the width. I know that 2 times 18.5 is 37, and I know 2 times 12 and a half is 25. If I add those together, I get 62. So the perimeter would be 62 feet. If you walked all the way around the outside of this rectangle, you would walk 62 feet. And you'd get the same answer if you added up all 4 sides. So lots of ways to do that. Your job is to find the perimeter of these 2 any way you would like. Pause the video and then come back and check it out. Hopefully you've had time to try these. 16.8 times 2 gives us 33.6. 27.3 times 2 gives us 54.6. So I'm going to add 33.6 plus 54.6. When I add them up, I get 88.2. And for this is centimeters. That means the distance around the outside, the perimeter would be 88.2 centimeters. For this one, 17.4 times 2, this piece right here, 17.4 times 2, we get 34.8. 2 times 8.6, we get 17.2, and we got to add those together. When we add them together, we get 52.0. So 52 inches is the distance around the outside of that rectangle.